available, but still there are exceptions, which is very important. What are the exceptions we studied there? Non-metals characteristics exception. Mercury is metal. Diamond is the hardest substance what we get, but it is a non-metal. Why? It is made up of carbon. Iodine is lustrous in nature, but most of them are dull in nature. Correct? So that is a one. Bromine is a liquid non-metal. So these are the exceptions we saw. And graphite. So graphite is a good conductor of electricity, but it is made up of carbon, or it is an allotropic of carbon. So, but it is a non-metal. So that is also one exception what we saw. Okay. So, so many exceptions we studied. Next, metals, we studied its chemical properties. So what are the chemical properties of metals? So in the chemical properties, we studied how it reacts with the oxygen. Then we studied how it reacts with the water, how it reacts with the acids and non-metals or other metal salts. Correct? So first one, how metals reacts with the oxygen. What happens to the metal reacts with the oxygen? It forms metal oxides. And reactivity series we studied. So first is the potassium, then comes the sodium, then comes the calcium, magnesium, then aluminium. Before that, lead.
Hydrogen is separating.
So tell me again, what are the
Potassium,
sodium, calcium, magnesium, aluminium,
zinc, iron,
yeah.
hydrogen, copper, silver,
Copper, mercury, silver, gold. So that is the reactivity series what we studied. That means how reactive are metals. At the top, they are the most reactive. Then it comes the less reactive metals we studied. So most reactive metals, sodium and potassium, vigorously reacts with the oxygen. It vigorously reacts with the oxygen. That means it reacts very fast with the oxygen, and it is a highly exothermic reaction. We studied that. It is a highly exothermic reaction. Since it is highly exothermic reaction, so what happens? When it reacts, okay, it is so much highly exothermic in reaction, it catches fire. Okay, so that is why sodium and potassium, it is kept in the kerosene, that is immersed in the kerosene, so that they don't react with the oxygen present in the atmosphere. Correct? So we learned that. Then what else we studied? What happens to other metals, calcium, aluminium, and all, when it reacts with oxygen? Aluminium and magnesium. What? Okay, tell me about aluminium and magnesium. What happens?
When they react with oxygen, they react slow and they form an outer layer to prevent further corrosion.
Aluminium will form aluminium oxide, so it forms a protective layer. Even magnesium, when it is exposed to air, it forms magnesium oxide, but a very thin layer is formed. So, and it becomes a protective layer. Al2O3 and magnesium oxide, they form a protective layer. Okay, so this protective layer will help in avoiding the further oxidation. It avoids the further oxidation of the metal. Okay, so this is why we study, and somewhere they will ask why it is used as utensils and all. That is the reason, because aluminium is used as utensils. Why? Because it forms the oxide but very thin layer, which itself acts as a protective layer, and hence it will not, further oxidation will not happen. Correct? No, but we can't use iron directly as utensil, because why? It will get rust. That is the reason. Then aluminium oxide, magnesium oxide we studied. Then what about other metals?
Blister copper react with oxygen.
Iron filings reacts. Okay. Silver and gold, they don't react. We studied that. How now metals reacts with water? Metal with water? Correct. What happens first? Tell me about sodium and potassium. Sodium and potassium. They react with cold water. Then what about hot water? If it is able to react with cold water, that means it will be able to react with hot and steam also. It is possible. If it can heat without heat only, it can react. Means with heat it can react, right? It can happen. So they react with cold water. When it reacts, what happens? So you will get metal. What you will get? Metal hydroxide. Metal hydroxide here. Sodium. Correct. With the water, you will get NaOH. You will get NaOH plus hydrogen gas. This is the list. So, what you will get? That it is since highly exothermic in nature, the whatever the heat is there, that itself is enough to catch hydrogen to catch fire. Do you remember? It was that
hydroxide with water. There's something with hydroxide with water.
yeah, Na plus OH.
With water.
Oxide with water.
It is like this plus water.
Just Na plus first it will form oxide.
Sorry.
First it forms oxide, then the hydroxide. NaO plus H2O. Then you can directly correct. Then you have the potassium. What will happen? It will form KOH, and that also, if you put it in the cold water, what happens? It catches fire because hydrogen gas produced will be what is the hydrogen gas produced in this also will catch fire because it's a highly exothermic reaction. And Rita, can you tell about calcium and magnesium with metals with water? Calcium reacts with water vigorously. Not vigorously. Slowly it reacts. What happens when you put calcium into the water? What happens now? Okay, what happens? What is it? It will be nothing will happen.
Nothing. It is exothermic, but fire only.
But what is the compound we are getting?
CaOH.
That is only reaction, no? CaOH twice. Correct. That only I am asking. Tell Karthik, what happens? Come now, Rohit here. Why are you sitting there here?
So exothermic process.
Clearly tell me now. Sunaina, tell me now. Sunaina, tell me now. What happens? Okay, Rohit, tell me. What happens when we put calcium into the water?
It forms calcium hydroxide.
Good. Then?
Anything else?
Then?
It's not a vigorous connection.
Then?
So,
Mohita, something else is there. When calcium is put in the water, what happens? You will get calcium hydroxide and hydrogen gas is released. So, what happens to that hydrogen gas? These gas bubbles will stick to the calcium. When it is sticking to the calcium, its density reduces or volume increases. So, it floats in the water. It floats in the water. Correct? What about magnesium? Whether it reacts in cold water? It reacts in a hot water. Magnesium reacts only with the hot water. What happens to the it's the same thing. Even hydrogen gas they are produced also sticks to the metal, and hence magnesium also floats in the water. We studied. Remember? Next, calcium done, magnesium. Then what happens to aluminium? Iron. Aluminium reacts with steam. Good. It reacts only with the steam. What happens to that? Aluminium oxide.
Nitric oxide,
Uh-huh.
zinc oxide.
Okay, correct. Aluminium, zinc, iron, they react with the steam. They don't react with the hot water. So when they react with the steam, they form the oxide, not the hydroxide. Correct? Aluminium forms Al2O3. Magnesium, not the magnesium, zinc. They form zinc oxide. Correct? And they react only with the steam. Okay. Now what happens to copper?
They don't
Uh, Silver, gold, they don't react. Okay. Then how they react? Metals reacts with the acids we studied, remember? Correct. Metals, how they react with acids. Yeah. Do you remember? Tell me how it will react. Metals plus what you will get? Hydrogen gas. Example?
Zinc plus HCl,
Hmm.
zinc chloride plus H2.
Zinc chloride. Is it correct? What I have written?
No.
What I have to write? Cl2. Zinc valency 2, chlorine valency 1, cross multiply Zn Okay. So what else we study? Metals with acid then.
Metals and non
What happens? Ionic compounds.
Base and acid, so then it will salt and water.
Salt and hydrogen gas. Not the acid and base. Sodium chloride C1. Salt plus metal with non-metal C1. It is salt correct. Other than that, it depends on which compound you are.
one strong things.
It forms ionic compounds, no? We studied, do you remember? And it is a salt. Forgotten?
Yes.
Yeah, while revising. Sodium chloride. Sodium plus chlorine. Sodium is metal, chlorine is non-metal. They together form a salt. NaCl. And they are ionic compounds. We'll study about once ionic compounds. Very important thing. Okay, in the chemistry, ionic bonds and ionic compounds. So ionic bond, I will explain again. Clearly listen. Ionic bond. How ionic bond is formed? When one substance is giving the electron and the other is taking the electron, then a bond is formed between them. So that bond we call ionic bond. Again, I repeat, ionic bond. In a chemical reaction, what happens? One substance will be giving an electron and the other is taking the electron, maybe one or more, okay, electrons, and it is taking one or more electrons. Then a bond is formed between the substances and it forms a compound. So that compound, we call it as ionic compound, and the bond formed will be ionic bond. Okay. For example, we studied sodium plus chlorine, we will get sodium chloride, NaCl. See, number of electrons that take part is called as valency. What is the valency? Number of electrons that take part in a chemical reaction, we call it as valency. So, sodium, how many electrons are there? 2, 8, 1. and here 288. So here it is ready to give one electron, and here it is 7 is there, no? Ready to take one. Here it is ready to give, and this is ready to take. So what happens? Sodium will give one electron. Okay, chlorine will take one electron. So there is a bond is formed between them. Okay, and that bond we call it as ionic bond. Okay, so sodium will become Na plus, this will become Cl minus. And here it is clearly given. Sodium is giving one electron, it is not taking it back. It is completely giving the one electron. Chlorine is taking that electron. So there is a bond formed between them because of giving and taking the electron. That bond we call it as ionic bond. And the compound formed by that bond we call it as ionic compound. Okay, so usually metals and non-metals, when they combine together, you will get ionic compounds. What is the reason? Metals are electropositive in nature, that is, they have a tendency to give electrons, and non-metals are electronegative in nature, that means they have a tendency to gain the electron. So they together, one will be giving the electrons and the other will be taking one or more electrons, and hence they form an ionic bond. And the compound formed by that, we call it as ionic compound. Okay, clear now? Write few things about that ionic bond. Write as ionic bond is formed. Ionic bond is formed when one substance is giving one or more electrons. Okay. Write down this. So one substance forms the ionic bond. Okay. Substance formed or the compound formed by ionic bond, they are called ionic compounds. So usually with metals and non-metals, when they combine together, we get ionic compounds. Okay. And ionic bond is a strong bond. Ionic bond formed, it is a strong bond. So they will have the compounds formed by that will usually have high melting point and high boiling point. Since to break that you need more energy, right? When it is strong, so they will have high melting point and boiling. Okay. Right, for zinc chloride, electron dot structure for zinc chloride. Zinc chloride, how we wrote for magnesium?
What is zinc valence?
2. Chlorine valency 1. So it is Zn 2 plus Cl minus. Right? Electron dot structure, what we wrote? See that? Electron. They will ask like this on the electron dot structure. Okay, first write the equation. How you will write? Equation for the Zn plus Cl, zinc plus chlorine Cl2, you will get Zn Cl2, you will get chlorine. This is equation. In the zinc, first thing, zinc valency is 2, chlorine valency is 1, cross multiply. One zinc reacts with two chlorine. That is why you will get zinc chloride. Correct? Na? Now, what is the in the outermost orbit? You have two electrons. We'll write dots for this. Two electrons for zinc. Correct. Next, in chlorine, you have 7 electrons in the outermost orbit. 2, 4, 6, 1, 7. 7 in the outermost orbit. Now, if they combine, what happens? We'll write 2 here. We have 2, no? So what it will happen? It will give one zinc, 2 are extra electrons are there. One it will give to chlorine and second one to the second chlorine atom. So what we will get here? We will get zinc. Okay, this is 2 plus. Chlorine, you will get its own 7 electrons are there and 1 electron it is given. For each one it is giving 1 electron. So it will become minus 1 and 2 are there, so 2 here. Again I repeat, see, in the zinc chloride, zinc has 2 extra electrons here. In the outermost orbit it has 2. So it will give 1 to 1 chlorine, second one to second one. So, and in the chlorine outermost orbit you have 7 electrons like this. So now what you will get, zinc 1 electron is given to 1 chlorine, second electron it is given to the second one. Now what you will get here, since 2 is not there, it will become 2 plus. That you write up. Okay, that it will become an ion. How many is there? That you write up. And here it will become 1 minus. How many atoms are there? Write it down. Clear, no? This we call it as electron dot structure. Example. Okay. Magnesium. Okay. Mg plus Cl2. It will get MgCl2. Okay. In magnesium also, it has 2 electrons. In the outermost orbit, 2 are there. So, one is given to one chlorine, the other to the other chlorine. So, what you will get? Chlorine, you have 2 chlorines. 2, 4, just to bifurcate, that's it. You can write both the dot or both the cross also, that is fine. If I write 1 dot 1 and this, you will know. That is the reason we are writing it. If you write both cross also, they will give marks. Okay, 2, 4, 6 and 7 are there. And here, in the outermost orbit, it has 7 electrons. 2, 4, 6, 7. Now, what you will get? One it is giving to this, second one to this chlorine. You will get Mg. Since it has given 2, it will become 2 plus. And in the chlorine, 2, 4, 6, 7. 1 it has taken from magnesium. No, each one will take 1 electron. In magnesium, since it is giving 2, but chlorine can take only 1. So, each one chlorine will take 1. Okay. So, chlorine will become minus 1 because it is taking 1. And here, how many chlorine atoms are there? 2. That extra you are getting confused. Just, Na is giving 1 electron. No? You can write that also. See, Na was giving 1 electron. So, it will become Na plus E minus. And chlorine, it is taking this electron. It will become Cl minus. So, it will be like, as a whole, Na plus Cl will be NaCl. These two I have not written from the understood. No need to write. To understand I written. Here, for this, we can write. See, zinc, it is giving 2 electrons. It will become Zn2 plus 2 electrons. Whereas chlorine, 1 chlorine will take 1 electron. So, it will become Cl. That's question of metal system. Okay. Only this part is there. If you finish, I think it's done. And then we'll go to little bit portions is there. Extraction of the metals. So we know that metals where we get in the earth crust, we will get the metals. Correct? In the earth crust, we will get the metals in the form of ore. In the form of ore, or we will get in the form of a mineral also. We will tell. Do you remember? We tell as a ore, mineral, everything. Correct? So, in the earth crust, we will get in the form of a minerals or ores. We get that if you do the extraction of the metal, then we will get the metal. That is iron ore. From iron ore, we will get iron. Aluminium ore, like bauxite ore, we call it as bauxite ore. From that we'll get aluminium, like that we will get. Okay. So in the, when we are getting is ore, so it will have the dust will be there. Okay. And it will be in the form of either some form it will be there. It may be a carbonate form, oxide form, that is metal oxide form, metal carbonate form, sulfide forms, some or the other form it will be there. So you have to do the some reactions has to be done so that we will get a pure metal. First you have to refine them, then you will get a pure metal. Okay. And what is the difference between a mineral and a ore? We are telling minerals are also there, ores also we will tell. Now, what is the difference between them?
Inside the inside the walls, that is the
In ores, from ore only we'll get the metal. What is difference between mineral and ore?
compounds which occur naturally, they are called mineral.
Both are naturally will get. Both we will get naturally.
Ores, it's like mixed with other things. In minerals, it will be pure, but
No, it is also mixed only. What is the main difference is?
Minerals from which metals can be extracted.
No, what is the main difference is ore is the one which contains more metal in that, so you can extract economically. See, for example, you want to extract the silver. If there, you have to dig that, so much procedure is there, correct? You have to dig it, then collect that, then you have to first dust all mud, whatever is there, you have to remove. Then you have to do the extraction, that is refining of the metal you have to do, then you will get. So it will cost more, correct? So yeah, if it is costing more than what we get in the market, for example, silver, what is the cost now? 1 kg is 1 lakh or something is there. So if you want to extract the silver, if it is costing more than 1 lakh, because the amount may be less in that, because of that, see, amount there, what you are getting. No, not everywhere it's the same amount you will get, correct? Some portion you will get more will be there, then it is easy to extraction get more wood, right? So yeah, 1 minute wait. See, if you are able to extract the metal economically from that, that we call it as a ore. If you are not able to extract economically from that composition there, we call it as minerals. That we call it as minerals. Ore means if you are able to extract from that economically, that is, if the cost is 1 lakh, if your extraction cost is less than that, economically you can extract from there, then only it is useful. No, in the market, if you are getting at 1 lakh, and if for the extraction, if you are spending more than that, more than 1 lakh, what is the use? No use. If you are able to extract in a less uh, amount, then only you will be able to use that, or you can sell that, right? So if you are able to extract the metal from that economically, we call that as a ore. Otherwise, we just call it as a minerals. That is the difference between an ore and a mineral. Okay. Now we will study about the extraction of the metals in this. So here also what we have, highly reactive metals are there, and less reactive metals are there, or medium reactive metals are there. So for each, depending on their reactivity, we will use the different methods to get the refining of the metals. Okay, we'll study about that. Right now. Two things. What?
So ultimately, what is the reform?
See, if you are able to extract economically from that, then that mineral we call it as a ore. Otherwise, we don't call that as a ore.
Ores are also
But when we specifically call it as a ore, if we are able to extract economically from that, then that we call it as a ore. Otherwise, we just call it as a minerals. Economically means,
Yeah. So why do you think that the gold prices were increasing? Because the availability is less now.
but still in some places if you are able to try to extract, you can't extract economically because it is very inside, it will be there, and if it is in less quantity or maybe the composition is very difficult to extract.
So
How in the market suddenly only you can increase the price? It is not possible, right?
that's literally how it works.
When you are the only person who are extracting, then it works. It is not like that. Now, many places they are extracting only, not only that, many other reasons also. It depends. If it is demand is there, then only it is there like that. So many things are there.
It's made into gold and
That is the only thing. You don't want to believe. It is like that. Right now, minerals contain. Uh, and sometimes no minerals, not all the minerals, they may not contain the high percentage also. It may contain the zinc, for example. Some minerals they will contain the zinc but not in a very high percentage, maybe 5 to 10% it has.
92.
Maybe some other composition can be there like that, then it works like that only. Like the minerals which contain. Cinnabar is the mercury ore. Cinnabar means it is the name is given for mercury ore from which mercury is extracted. Whereas a bauxite ore means aluminium ore. It is an aluminium ore. Okay. Steps involved, I'll explain. Steps involved in the extraction of metals from ore. Write down this. Aroma, it is pure metal. Then you will get purification. See, metals of high reactivity, electrolysis of molten ore, pure metal. Pure metal. We'll get the pure. Oxide of metal. Then comes the reduction of metal. Then comes the purification of metal. Or shall I write another? This much you have written. Until this, if you have written, I'll write it. Roasting. And then comes the oxide of the metal. Then comes the reduction of metal. Then purification of the metal. You know this chart very easy to learn. That's it. First one it is done. Second one. Okay. So again I repeat here. Carbonate ore, sulfide ore. Calcination, here it is roasting. Together it's the same next one procedure, that is oxide of the metal. From there it is a reduction of the metal, then to purification of the metal.
And again, sulfide.
Here in low reactivity, most of them will be sulfide ore. From there it is roasting, then metal, then that will be refining.
So,
After getting the metal, it is purified again.
so sulfide ore has stable reactivity and
Uh-huh.
reactivity.
You remember silver, it only reacts with sulfur. It don't react with any other thing. So then silver, if you are getting as a ore, maybe fully silver you can get as a metal itself or sulfide ore. Because they don't react with, they would have not combined with anything else. No, most of them. It is not all. Understood why it is only sulfide they have given like that. Because silver, they don't react at all with any other thing, then you will not get like that. Either in its pure form or maybe with the sulfide ore, it will get like that. That's why they're doing it. I think in coffee wood they're getting this one. Ganesha, I think. They're told. The 3 days it's a program is here. They say it's nice.
I would like to see you cook.
No, I said cook and put on that. Why you like?
Only you can think like that, I think.
I don't know, it's sure.
That's what only you can think. Others will think as crackers. Huh?
So smart.
Okay. Written. Okay, write down today. Tomorrow we'll study about this thing. This is very interesting topic actually. Metals with high reactivity, how it will react, how you can extract, medium reactivity, then the sulfide. And many questions come from this part. More questions come from this part of it. Here we will end the today's class. Do not forget to subscribe the channel. If the content of this channel is useful, please like the video and share with your friends. Thank you.